In section 4.3, we learn how to solve absolute value equations and inequalities. So first, we should probably review the definition of absolute value. The absolute value of a number is its distance from zero on the number line. The notation that we use for absolute value is these vertical bars here. And so if we have the absolute value of u, this is the distance that u is from zero on the number line. So for example, if we have the absolute value of -8, we can locate -8 on the number line, and we can see that -8 is 8 units from zero. Therefore, the absolute value of -8 is 8. Likewise, if I have the absolute value of a positive number, like 5, let's say, we can locate 5 on the number line, and we can see that 5 is 5 units from zero. Therefore, the absolute value of 5 is 5. And as a special case, the absolute value of 0 would of course be 0 because 0 is 0 units from itself. Now, when we talk about equations, we're talking about solving equations involving a variable. So let's suppose we have the absolute value of x is equal to 3. What that's saying is that x has to be a number that is 3 units away from 0. And there are two possibilities. -3 is clearly 3 units away from 0, and so is +3. Therefore, if the absolute value of x is equal to 3, x can either equal 3 or x can equal -3. So then, how do we solve more complicated equations where the inside of the absolute value is something a little bit more complicated than just having x? Let's take a look at some examples. So if we're given the situation where we're trying to solve an absolute value equation, and we have the absolute value of u is equal to some number a, and we will assume that a is a positive number, then the only way this can be true is if u itself equals a, or if u is equal to the opposite of a. And so for a first and simple example here, consider the absolute value of x is equal to 5. By the definition above here, this can only be true if x itself equals 5, or if x is equal to -5. And so these are our solutions. And we can write them like this, or we can say x equals -5 or +5. That is acceptable. We could say x equals -5, 5. And finally, sometimes you will see them written as a solution set. So it doesn't really matter which way you write them. And so for the remainder of these problems, we're going to write the answer like this. Okay, next example. Suppose we have the absolute value of 2x minus 7 is equal to 13. See, the whole point is whatever is inside the absolute value can only be 13 or -13 if its distance from 0 is supposed to be 13 units. So that means to solve this equation, we need to set 2x minus 7 equal to 13, or 2x minus 7 equal to -13. And then all we need to do is solve these equations separately. And each of these are relatively simple linear equations. And so if we do the math here, we end up getting two solutions. We have x equals 10 or x equals negative 3. And we're going to write the answer using a comma, 10, comma, negative 3. Please don't put any parentheses around your answer. We leave it just like that. Okay, so for the next problem, it's the similar type of problem to the last one. We have the absolute value of something is equal to 12. Notice that it doesn't really matter what you have on the inside of your absolute value. For this to be true, whatever is on the inside must be equal to 12 or negative 12. So to solve this, I'm going to set 5/3 x plus 2 equal to 12, or 5/3 x plus 2 equals negative 12. And then we just have to solve. So what I'm going to choose to do here is subtract 2 from both sides. This gives us 5/3 x equals 10. And then I'll multiply by 3 over 5 on both sides. And this will give us x equals 10 times 3 is 30, divided by 5 is 6. And then we solve the second equation the same way. Subtract 2 from both sides. We get 5/3 x equals negative 14. Multiply both sides by 3/5. And we end up with x is equal to negative 14 times 3 is negative 42 divided by 5. And this is our answer. All we need to do now is write them by separating them with a comma. So it's a relatively straightforward process. I do want to point out that when you're doing this, the whole point is that to solve an absolute value equation, you have to get rid of the absolute value symbols. And we do that by setting whatever is inside equal to this number or the negative of that number. Whatever's inside the absolute value, though, that does not change. So notice that 2x minus 7 is the same here and here. It's the number on the other side that changes. Okay. Number 4 is a special case. We have the absolute value of 3x plus 1 is equal to negative 9. And if you're not careful here, you could get the wrong answer by setting up an equation here. See, the thing is, the absolute value of a number is the distance from 0. Distance is always a positive number. So the absolute value can never be equal to a negative number. So this is a kind of a tricky question here, but this problem has no solution. So you have to pay attention. You have to make sure that your absolute value is equal to a positive number before you can set up your equations and solve. Let's consider the next example. So to solve this one, what I need to do first is I need to get the absolute value by itself. So I'm going to start by subtracting 9 from both sides. And that gives us negative 4 times the absolute value of 5x plus 6 is equal to 0. And then I can divide both sides by negative 4 to cancel. And after we do that, we have the absolute value of 5x plus 6 is equal to 0. Now, we already said that an absolute value can never equal a negative number, and you know that if it equals a positive number, you'll have to set up two equations. Well, when the absolute value is equal to 0, the only way that can be true is if the number inside is equal to 0. So again, you need to write the equation without the absolute values before you start solving for x. And so for this one here, when we divide by 5, we get x is equal to negative 6 over 5. only one solution. Okay, and now our last problem is even more special because we have an absolute value on both sides of the equation. To solve this one possible solution is that whatever number inside of here equals the number inside of here, because if two numbers are equal, they will have the same absolute value. So one possible equation is 4x plus 3 is equal to 3x minus 5. And then we can solve that equation. But that's not the only solution. The other possibility is that the number inside of here equals the opposite of the other number. And so for that to be true, we would have 4x plus 3 is equal to the opposite of 3x minus 5. And then we go ahead and solve. So for this one, we'll subtract 3x. And then subtract 3. And we end up getting x is equal to negative 8. For the other equation, we distribute the negative, add 3x to both sides, subtract 3, and finally divide by 7 to get x equals 2/7. And so this one has two solutions. And again, we should write that answer in a comma delineated fashion. All right, so again, the key takeaway here when solving absolute value equations is that you need to get rid of the absolute value before you start adding and subtracting things to both sides. Notice that. Before I start adding and subtracting anything to cancel the numbers on the inside, I need to write these without absolute values first. Okay, let's move on to absolute value inequalities. So we're going to start with the absolute value inequality where we have an expression like the absolute value of u is less than some positive number a. Now, this means that u needs to be between a and negative a. And let's think about why that is true. If you have a number line and zero's in the middle, and let's say positive a is over here and negative a is over here, if the absolute value of u is less than a, it means that u has to be a number that is less than a units away from 0. So the only numbers that are less than a units away from 0 are all the numbers in between negative a and positive a, which is exactly what this means. So let's see how to apply this to an example. So if we want to solve the absolute value of 2x plus 3 is less than or equal to 7, it means the number 2x plus 3 must be between positive 7 and negative 7. So the way we write this without absolute values is 2x plus 3 must be less than or equal to 7, and it must be greater than or equal to negative 7. And so now we have a double inequality, and all we need to do is solve that double inequality by doing the same thing to all three parts. And so when you go through the motions here and you solve for x, you end up getting x has to be a number in between negative 5 and positive 2. And in interval notation, that looks like this. Okay, our next example is very similar. We have the absolute value of 4 minus 5x is less than 8. For that to be true, the number 4 minus 5x must be in between negative 8 and positive 8. And by the way, if your less than symbol has no equal sign, then you put no equal sign here. In the previous example, we had an equal sign, and so we carry that down below. So whether it has an equal sign or not, you pretty much set it up the same way. Now, to solve this for x, I'm going to take away 4. This gives us negative 12 is less than negative 5x is less than 4. And then we have to divide by negative 5. And when you divide by negative 5, you get positive 12/5. And then remember, when you divide by a negative, you have to switch the sign on both of those. And then 4 divided by negative 5 is negative 4/5. Now, anytime you have a double inequality and you switch the signs when solving for x, you need to switch them back by reversing the entire inequality. So basically, we're going to switch these two numbers and reverse these signs. And that says the same thing, but it has your numbers in the proper order now. And in interval notation, this would be all the numbers in between negative 4/5 and 12/5. Okay, now for our final example here, we have the absolute value of 3x plus 2 is less than or equal to negative 6. Now remember, an absolute value must always be a positive number. So no matter what you plug in for x, after you take the absolute value, this will always be positive. And a positive number is never less than a negative number. So this is another tricky one. This one has no solution, because no matter what value of x you plug in there, it will never be true. All right, let's look at one more situation involving inequalities. So for our final examples, we're going to look at absolute value inequalities involving a greater than symbol. And the absolute value of u is greater than a means that the number u has to be less than negative a, or the number u has to be greater than positive a. Let's think about why this is true. So here's a number line. Here's 0, here's positive a, and here's negative a. When you say the absolute value of u is greater than a, you are saying the number u is more than a units away from 0. If a number is more than a units away from 0, it has to be either out here or it has to be out here. And so this is x is less than negative a, and this one is x is greater than positive a. So when doing this, you have to set up two separate inequalities. It's very different from when you do the less than situation. So for example, if the absolute value of 2x minus 5 is greater than 11, that means one of two things. It either means that 2x minus 5 is less than negative 11, or 2x minus 5 is greater than positive 11. Once you have that set up, it's very simple to solve these. You go through and do the same basic steps that you have been doing when solving linear inequalities. And so that first inequality becomes x is less than, negative 3. And then solving the second one, we end up getting x is greater than 8. So the solution is either x is less than negative 3 or x is greater than 8. Let's graph those solutions. So x equals negative 3 is here. X equals 8 is here. And either x is less than negative 3 or x is greater than positive 8. And so in interval notation, these are all the numbers from negative infinity up to negative 3, not including, union all the numbers from 8 to infinity. And so here is our answer in interval notation. Let's try our second example. So again, if the absolute value of negative 4x plus 2 is greater than or equal to 7, either negative 4x plus 2 is less than or equal to negative 7, or negative 4x plus 2 is greater than or equal to 7. Notice that I'm setting it up the exact same way that I set up the last one. And then we simply solve. Divide both sides by negative 4. When you divide by a negative, the inequality reverses. And negative 9 divided by negative 4 is positive 9/4. Solving the second one. We end up getting x is less than or equal to negative 5/4. All right, so now we're going to graph it and put the answer in interval notation. I won't draw a fancy graph for this one. We have x is greater than 9/4, or x is less than negative 5/4. And it's actually greater than or equal to and less than or equal to. So our graph looks like this. Notice that I don't need to graph other numbers on the number line. This is all I need. So in interval notation, our answer is all the numbers from negative infinity up to a negative 5/4, union all the numbers from 9/4 up to infinity. Okay, and one final example, and you should be suspicious right away because we have a negative number on the other side. Remember, no matter what x is, no matter what number you plug in, when you compute this value and then you take the absolute value, this will always be a positive number. And a positive number is always greater than a negative number. So we can plug in any number we want for x. So the solution here is all real numbers. Or you can also write that in interval notation as negative infinity to positive infinity. Okay, so this concludes our discussion about absolute value equations and inequalities. Time to do some work.